Hello again, this is Howie, and in this video we're going to continue working with fractions, specifically adding fractions that have different denominators. Let's continue using the example of a candy bar. Don't worry, I'm going to share some with you. This represents our whole candy bar. And just like before, let's divide our candy bar into 3 equal parts. 2 vertical cuts, 3 equal parts. And those 3 parts we break the whole into represent the denominator. I'm going to be especially nice this time and give you 2/3 of the candy bar. Those 2 parts represent the numerator. Unfortunately, word has gotten out that I'm a good sharer of candy bars, and I'm going to have to share some with your friend. I tell your friend she can have 3/8 of the candy bar. The denominator of 8 tells us how many parts we need to divide the whole into, and then your friend gets 3 of those 8 parts. I made 7 cuts to create 8 pieces, and then I can go ahead and give your friend 3 of those pieces. So your friend gets 3/8 of the candy bar. So who's going to get more candy bar? Well, as you can see from the model, you will. You're welcome. But wait a minute. Did I make a mistake? Did I just give away more than my whole candy bar? Will I need to buy another one? What do you think? In order to find out exactly how much candy bar I gave away, we're going to need to find the sum of 2/3 and 3/8, and that's a bit of a tricky problem. As you can see, each bar is broken into different sized parts based on the denominator. In order to add 2/3 plus 3/8, we need to get these parts to be the same size, without changing the amount of candy bar you or your friend get. That's called finding a common denominator. I'm going to share one really helpful strategy to find a common denominator, and it has to do with the way that we draw the models. I'm going to go ahead and represent 2/3 once again in a model. I'm just going to make the model slightly bigger so I have some more room to work. Now I'm going to go ahead and draw a new model to represent 3/8. You'll notice that I start with the same size whole. But unlike our first model, I'm going to divide the whole into 8 equal parts using horizontal cuts. This will make it much simpler for us to create equal-sized parts for both of our models. I will now shade 3 of those parts to represent the 3/8 of the candy bar your friend gets. And now we are ready to find a common denominator so that we can add these fractions. To do so, it's just a matter of sharing. We're going to share the red vertical lines with the 3/8 model, and the blue horizontal lines with the 2/3 model. Let's see a replay. Copy the red lines to the 3/8 model. Copy those blue lines onto the 2/3 model. Now both models have exactly the same size parts and exactly the same number of parts, 24. That means the new denominator of our fraction model is 24. And instead of having just 2 parts shaded yellow, we now have 16 parts shaded yellow. 16/24. Although the numbers in the numerator and the denominator look very different than the 2/3 we started with, the value did not change at all. Notice how the part shaded in yellow stayed the same. That's because 2/3 and 16/24 are equal. We can call them equivalent fractions. 16/24 is one of the nicknames of 2/3. Our initial model started with 3 parts, and then we broke it into 8 times as many parts. As a result, you will also receive 8 times as many parts. In the fraction model that started with 3 out of 8 parts shaded purple, we now have 9 out of 24 parts shaded purple. And just like before, the fraction that we started with, 3/8, is equivalent to 9/24. All we did was break the candy bar up into 3 times as many parts and allowed your classmate to take 3 times as many parts. Now that we have common denominators, we can go ahead and add 2/3 and 3/8, or 16/24 and 9/24. Remember, each of the parts in the model represents 1/24 of the whole. We can simply count up the number of 24ths that are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 24ths. Of course, we could have just added 16 plus 9, which equals 25. Notice how the size of each part doesn't change. Each part still represents 1/24 of the whole. We do have a bit of a problem, though. Because there are just 24 parts in a whole, that means I'm giving away more than my whole candy bar. And yes, I do need to buy a second. 25 24ths means 1 whole and 1/24. That's 1 whole candy bar and 1/24 of a second candy bar. Now it's your turn to practice adding fractions with unlike denominators. Draw a model to represent each fraction. Remember, the denominator tells you how many parts to break the model into. The numerator tells you how many parts to shade. Try to make one model using vertical cuts and the other model using horizontal cuts. Then bring them together to find the common denominator. Pause the video, then press play to check your work. (11 tenths), or 1 and 1/10.